Yeah, good day, my viewers all over the world. I remain Salumaj, and today we'll be talking about physics. And under this physics, I would like to talk about work, energy, and power. Work, energy, and power. If you are in SX1, if you are in SX2, if you are in SS3, or you are in the university, I want you to pay a very good attention to this my lecture on this topic: work, energy, and power. The question is, what is work? Very simple analogy. You are going to understand this. You don't need to cram anything when it comes to physics. Physics is practical. Chemistry is practical. You don't need to cram anything. Once you understand it, you have understood it. There is no two way about it. Just follow it. Follow what I'm doing. I'm an environmental teacher. I use what I see around to do my teachings so that if you wake up in the next moment, next year, 10 years to come, and you are being asked about that very particular topic, you still have something tangible to say about it. So don't cram in my class, please. Just follow my instruction. Physics is very exciting, very sweet. So the question is, what is work? Work. Don't cram. I will explain. Don't cram anything. Let's say I have an object. This is an horizontal floor. I have an object here. Let me just turn me to be a stone. This is a stone. This is a flat floor. And if you look at it, this object, which is a stone, is on a resting floor. Don't forget our first law of, Newton's first law. You know, the law states that a body will continue in a state of rest, like the way we have here. You know, it's not moving. The body will continue in this position. That's what the first law of Newton, as Newton's first law is saying, that this body will continue to be till eternity. A body will continue in a state of rest or uniform motion. Uniform motion that it will continue to move as it is now. It can continue to move. That's the first law. It can continue to move. Either it remain in a state of rest or it continues to move, provided it is not being acted upon by an external force. As this stone is now, if I roll it, Newton's first law is saying that this thing will continue to flow. It will continue to move till eternity. But the only thing that can stop this stone, it is when it is being acted upon by an external force. Let's say I roll this stone and somebody is standing here and the person stops it. The stone will stop. That's what the first law is saying. It's either the stone remain in a state of rest, the one you have here, or it will continue to be in a uniform motion, provided it is being acted upon by an external force. So here, I just cheat that in. So here we want to talk about work. In the work, what we have here is that this stone is on a resting surface. If I shift this stone from here to this place, if you look at it, I've moved the stone from point A to point B. What you have just simply done is what is called work. You have changed the position of this stone from its resting point to another place. What you have done is called work. WWORK. Work. Then the energy that you have used, or what you have used to move this stone from point A to point B, is called energy. I'm coming to that. So the last say work. Work is calculated as force times distance At a point, I will call it as force times perpendicular distance. That's where we are dealing with equilibrium. Also in vector, I'll be talking about this. Just follow me that work is equal to what? Force times distance. I may ask you, what is force? Force is what? Mass times gravity. As you can say F is equal to mg. At times, your F can be equal to ma, depending on where you are acting your force. If you are acting against the true gravity or towards the gravity, you talk about what? Mass times gravity. But if you are moving perpendicularly to the gravity, you talk about what? Force is equal to what? Mass times acceleration. You are moving perpendicularly. This is your force moving. This is your acceleration rather. So you say force is what? Mass. This is moving against the gravity. Sorry, perpendicularly to the gravity. So we say force is equal to what? Mass times acceleration. So we have already derived the distance that force, a walk, is equal to what? Force times distance. That is work. If you want to do any calculation, I may say that if a truck has a weight or a mass, then assume that a truck or a stone, let's say this stone has a mass of 2 kilograms. This mass or this stone has a mass, or let me just walk straight so that I don't need or I don't want to waste time. Instead of saying that force is equal to ma or to no. Force, let's say this stone has a force of 20 Newton. You have used 20 Newton to move this this stone from point A to point B. And let's say the distance from point A to point B is let's say 15 meters. I may ask you, what is the work done? So it will now be what? Work done is equal to what? Force times distance. So we now be that work is equal to what's the force? 20 Newton times what's the distance covered? 15 meter. So we now say that work is equal to what? 15 times 20, that is 300 joules. Joules, which is J. So work is measured in joules. So for energy also, energy is also measured in what? In joules. And they will ask you, energy. There are two types of energy. We have the kinetic energy and we have what? The potential energy. Why this stone is still at rest? It will have potential energy. But as it is moving, potential energy is converted to kinetic energy. It's just an English word. Potential. This thing has the ability to do something, but it's still latent. It's still what they call it, stable. But kinetic is in motion, meaning that your energy that is in motion, I can ask you, energy that is in motion is called what? Kinetic energy. Then we have other types of energy. No matter other types of energy they are talking about, everything will still be grouped under potential energy or kinetic energy. For instance, they may be talking about ionization energy, chemical energy, mechanical energy, electrical energy, nuclear energy. Any of the energies they will be talking about, we're still going to group them under kinetic energy and what? Potential energy. I think that is clear. Let me just recap it. When you're talking about using this stone as a typical example, when this stone moves from here to here, moves from A to point B, we say that work is done. Then what you have used to move the stone from point A to point B is called energy. That is different between work and energy. Work is talking about displacement. If there is no displacement, work is not done. If there is no displacement, work is not done. That is, if this, but that's why I stated the Newton's first law of motion. If this thing remains like this, nothing is done, no work is done. But immediately this thing is shifted from ear to ear, work is done. But what you have used to carry out this process is called energy. It's called energy. So let's go to power. And I've given us the unit for work. I've given us the unit for energy. Energy is also measured in joules. Energy is measured in joules. Then let's talk about power. In our general definition, they will tell you that power is the ability to do work at a particular time. Time must be fixed to it. So meaning that power is equal to work done at a particular time. That is work done, work over time. Thank God we know how to calculate work done. That is force times distance all over time. And meanwhile, they may even ask you one of those questions, the might ask, I remember them with you right jam, that what is the dimension of power? You know, remember dimension, you first have to break this order that what is work done? Work done is mass, yes, force times distance. What is force? Mass. What is mass? M. Distance, L. That's dimension. So I'll still talk about dimension later. So here we are talking about power. Power is equal to what? Work done all over time. Meaning that you can have force times distance all over time. I'm trying to break down this, what they call it, formula. And we know that work done, the unit of work done is what? Joules. When you multiply Newton by distance, which is meter, you are going to get what? Joules. I can say force Newton times distance will give you what? That is what? Joules. Joules. It give you joules. So when you now say joules per seconds, joules per seconds now, joules per seconds, we have, no, this is joules all over time. The standard unit of time is what? Seconds. So power is what? Joules per seconds. The question is, another one, if I don't want to be mentioning joules per seconds, I'll just immediately say that power is equal to watts. So I can say what is watt? Watt is also what? Joules per seconds. I can say what is watt? Watt is what? Joules per second. So you can see that the three terminologies, they are very simple. So if you are given any question, they say that if, okay, let me just give us one question to drive home all what I've been saying. If a truck of, let's say if a truck of 500 kilogram is lifted to a distance of 5 meters, to a distance of 5 meters. The question may say for 15 seconds, or let's say for 2 minutes. So they use 2 minutes to lift this 500 kg truck to a distance of 5 meters. The question is, what is the power? What is the power? Or they may ask you, what's the work done? You can't get the power without getting the work done. So if I just say, what is the power? I just went straight, say, what is the power? What is the power? I know that power is equal to what? Work done all over time. So how do I get my work done? Work done is what? Force times distance all over time, which is in seconds. So if, like I told us while teaching us mathematics, I said no matter what the question you're being given, you first write out the preambles. Write out the preambles, those things you are given in the question. First write it out. So if I write this one out, I will have let's say the truck is what? 500. The mass is equal to, as the weight of the truck, the mass of the truck is 500 kg, is given to a distance of, the distance moved 5 meters, then the time is 2 minutes. So if you now substitute this into the formula, You know that this formula is what? The work done is force times distance. If you look at this is kg. And I told us that force is equal to what? Mass times gravity. Because you are lifting object, well, you are moving against the gravity. So if you are moving against gravity, the gravitational force is constant. And it's given as what? 10 meter per second. So we now have force that is 500 kg times 10. That is the force times the distance. What's the distance? This distance is what? 5 meters times 5 meters all over the time, which is 2 minutes. So you convert these minutes to the standard time. What's the standard time? Seconds. So if I want to convert these 2 minutes to seconds, now say what? 2 times 60. So you know that 60 seconds make 1 minute. So 120 seconds will make 2 minutes. So we have 2 times 60. So this is now in seconds. This is kg. This is oh no, this is let me just go so that I don't waste time. So you now do the division, this multiplication now. This cancels this. 2 goes, or let's say, okay, 2 goes here, 1. 2 goes here, 250. Is that all? Yes, so we have 250 times 5. That is what? 250 times 5, that is 1,250 divided by 6. So 6 goes in 12. That is what? 2. Can 6 go? Okay. 6 goes in fact, no, not possible. Then in 50. That's 6 times 6 times 7 times 8. That is it. That's 48. So you have 8, remainder 2. That's 2 over 6. So we now have it to be 28 whole number 1 all over 3. You can use your calculator to get 28.3333. That would be 28.3333. And leave it in 4 decimal place if you use calculator. No, I'm not using calculator, I'm just solving it all fun. So you can now see the way we have. So that answer will now be 28.3333 watts or joules per second. So we have determined what the power is. Along the line, they may not even talk about calculate the work done. They will just say you calculate the power, the way I've done here. But you can't get the power without getting the work done. I believe I've made myself so explicit in this topic. So I believe every one of us can now solve any question related to work, energy, and power. So you watch out for my next video where I'll be teaching equilibrium vector. So please don't miss that class. Please subscribe to my YouTube channel. I remain Sir Lumaj. Like this video, share it to your enemies. Let them also get knowledgeable. And meanwhile, if you are in Nigeria, we have started our pivots. If you have not heard about it, please, the pivot, if you are in secondary school, please tell your principal they should go and register. The thing started March 25th, and the competition is beyond. So don't miss out in this event. God bless you all for watching my channel. I remain Sir Lumaj.